how well I play compared to you. We're going to talk about energy and heat again. And one of the things that we really want to focus on today, because we're going to set this in motion now, and I think it's more for you guys. A lot of you guys are seniors, or you're not coming back next year, right? All right. So
all shit's coming back.
I'll be back.
One of the promises that we made when we put this project together was that we would work as well as we could to integrate some of the stuff that you're learning into the actual project. And there's a lot of reasons for that. One, at some point in your life, you'll realize that you need to get a job if you haven't already. And it's my opinion that this field is going to be a huge field coming forward. The whole concept of how we deal with energy and electricity and how we build buildings is becoming increasingly important. And the people, what I see in the field is a lot of the building companies and architects and construction companies, the ones that are surviving through this economic downturn are the ones that are dealing with this topic, because more and more people are now aware of the fact that it's not just how much you pay to put a building on the ground that matters, but how much it costs to operate it. And so the effectively built buildings with the innovative systems that save money and save electricity and save heat, those are the ones that the guys that got jobs right now. And the other thing, and this is just being strategic with you guys, a lot of the old school builders and everything, they just don't want to change their ways. And so it's going to be this new wave of people that think differently that are going to take over these fields. And so that has meaning to me. And so we thought that we could at least show you, yes, our boiler is relatively standard, but the microturbine is not, and the solar array is not. And those are the kind of things that we want to integrate into your classes if we can. Now, we've come up with another strategy that we're going to try and put together here over the next few weeks, and that is we want to try and get you guys to come up with a project here that you want to do. Now, we can use some creative ways to come up with some money and support to get that project off the ground, and working with your teachers and your own ideas. You need to come up with the goals and the objectives, lay out the plans, put this stuff together. We'll get the equipment if you need it, and then you can build the project. And one of the keys that we want to focus on is getting it done before the end of the year, so those of you that are leaving can actually see it done. The only thing I really need to share with you today to kind of give you that background is another, most of the pre-engineering students have received a little bit of this information, but I want to give the welding and construction and the other guys a little bit more background on how these projects work, how buildings use energy, and some ideas, so that hopefully over the course of the next week or so we can come up with a project. Some of the topics that we talked about in other class, I'm going to talk about them. Has anybody in here heard of a LEED building or a LEED certified building or anything like that? It's LEED, and it's a process created by an entity called the U.S. Green Building Council. Whenever a building gets built and it's LEED certified, it's guaranteed a newspaper article about it, at least for the time being, because it's a fairly rare process. LEED has different levels depending on how energy efficient. It's leadership in energy and environmental design. So however well the building is built on this scale, you get these ratings. You can have a certified building, a silver, gold, platinum, and then there's this fifth category that they're talking about, but they haven't completed it yet. The idea would be that the building is a net zero building. And net zero means that the building basically has no impact whatsoever. The idea is that it's like completely recycled, that it generates as much energy as it uses, that it recycles its own water on site, all these kind of really aggressive criteria that you basically drop a building on the ground and it should arguably have no external impact that's negative to the environment. There are about as far as I know, there are about 5 to 7 buildings in the state of New Hampshire that are platinum. There's a bunch of gold ones and even more silver and certified. So this is kind of an external score sheet that you go through when you build a building. You turn the plans into these guys, they review it, they tell you whether it's okay or not, and then you go out and build it. You have to have a lot of inspections during the building process to make sure it's done correctly. And then most importantly, at the end, you have to go through this process called commissioning, whereby you prove that the building is operating the way you said it was. Too often we see a lot of buildings that are designed right and built right, but then they're operating wrong. And they make these mistakes and nobody goes in and finds out that they've done them. So, one of the critiques about the LEED process or the LEED buildings is that it costs a lot of money, and that's kind of the problem with any kind of energy efficient design. But in fact, all the research shows that if you go for one of these two levels, it either costs the same or there's a 1.5% increase. When you get up into gold and platinum, you start seeing more increases because you have to spend a lot more time doing stuff. It's a little bit more expensive. But on the other side, it costs a heck of a lot less to run. You know, usually in the platinum level, you find some kind of solar PV array or a solar thermal array. And in that case, once you put those facilities up, they generate heat and electricity for free. Okay? So let's talk about buildings again. Today is an interesting day. It must be 70 degrees outside, but the boilers are not running. But in general, in November, you would get your boilers running, and you have two major issues in New Hampshire: heat and electricity. And it turns out that, just to show you the scale, this campus, I'm trying to remember these numbers. This is the annual expense on this campus for electricity, and then for heat. Well, let's put this. When oil was 3 something a gallon, you were spending $400,000. This year, it'll probably be $175. So in this building alone, you're spending, you know, around $400,000 a year to heat and power it. And so you can see that if you save 10%, you can save a legitimate amount of money. Now the high school is a little bit more frightening. The high school on electricity is about $500,000, and the heat is even more scary at about $650,000. So you're about $1.2 million at the Exeter High School to heat and power that building.
Taxpayers' money.
Taxpayers' money, that's right, going straight into whoever's pocket. So the idea that with those budgets, and we want to focus on this building or these buildings here because they're closer to you, but the idea that we can find a project that not only makes a lot of sense for you learning, but can actually save money, and then we can actually measure it, and you can say, here's how much money we saved. I think that that's a much better idea. So we're going to expose you to the installation of the boiler, we're going to expose you to the installation of the microturbine, and we're going to have a build day in December where everybody comes on site and helps us with the solar arrays. It looks like it's going to be December 4th. But in addition to that, what we want to do over the course of the next 9 months or six to 9 months is come up with a way that we can do something at these buildings to actually save money for this campus. So, the issues with heating a building. You have your central power, you have your heat plant, and it distributes heat throughout the building in all different ways. And there's obviously efficiencies in how that is done. The other problem is, like we did on the tours, you see that on the second floor over there in the Tuck campus, or I don't know, the old high school building. You see all the people have the windows open. Even in the coldest day of the winter, we see that because to heat the lower part of the building, you have to heat the upper part first. We can come up with some strategy to deal with that. That's obviously not the way you want to heat a building. In terms of insulation, we can look and see what these windows and walls are made of and see if there's any way to check that. All this stuff has been measured in terms of the heat. We get the heating bills, and so we can see how much we get. On the electric side, we'll go over here now. On the electric side, we actually have every 15-minute, what's called 15-minute interval data. So every 15 minutes, the utility logs exactly how much electricity these buildings are used, and we have that data. And so we can compare 1 year or 1 day to another day, and we can try and come up with ways to shave off some of the electric use in these buildings.